career guidance, parenting, pedagogy, coding classes, usage of technology, cyber security, general awareness program, and many more. We have conducted many hundreds of webinars with about 1 million participants in the last 3 years. The technology arm of Goyal Brothers Prakashan, Bright Tutee provides online digital learning content for the K-12 level in a variety of languages for more than 20 educational boards in all of the major subjects.
So now we have Mr. Shaurya with us. Mr. Shaurya is our subject matter expert. He's an author, editor, having a lot of experience. So he's here to discuss the paper. So sir, the platform is all yours now. Thank you so much.
Thank you. Good evening, everyone. Teachers, my beloved students, I welcome you all on behalf of Goyal Brothers Prakashan in this webinar. We have all gathered here to discuss today's CBSE Term 2 Mathematics Standard question paper. So I like all of you to just go along with the flow. I have snips. I recently basically received the question paper. So what I could manage to do is take snips and I pasted it in a presentation. So from here, I'll solve it on. So as we all know, our question paper today had 3 sections. Let me just present my screen first. Okay, so here we are. So as I was saying, today's question paper for Maths Term 2 Class 10 had 3 sections. Section A had 6 questions, out of which 2 had internal choices in them. Section B and C had 4 questions each, while section B had questions of 3 marks, section C had questions of 4 marks each. In section A, all the 6 questions were of 2 marks. So we can begin with the first question. It is a straightforward question. Just a minute. Yes. Find the mode of the given frequency distribution. Yeah. So first, we need to find the modal class. We can see here the maximum frequency lies in 45 to 55. So this becomes our modal class. So now the formula for mode for a continuous frequency distribution, as we know, is L plus F1 minus F0 by 2 times of F1 minus F0 minus F2 whole multiplied by H, right? I hope everyone knows the obvious symbols. L is the lower limit of the modal class. F1 is the frequency of the modal class, F0 the frequency of the preceding class, F2 the frequency of the successive class, and H being the class size. So we can just plug in the values and we'll have the answers to ourselves. So lower limit of the modal class is 45 plus frequency is 23 minus 22, that is the frequency of preceding class, 35 to 45, whole divided by 2 times of 23 minus 22 minus the frequency of the next class, which is 14. And this entire thing gets multiplied with H, that is the class size, which is 10 in this case, right? Okay, so I guess we can do the maths from here on. It's 1 upon 46 minus 36 into 10. So it's like entire 10 upon 10 got cancelled. Answer would be 46, right? So the answer we have here is 46 is the mode of the given frequency distribution. We can come to the next question. For what value of n are the nth terms of the AP 9, 7, 5, and so on, and 15, that is the second AP 12, 9, and so on. This is 12, right? Yeah. So for what value of n are the nth terms of these two APs equal? So we have a basic formula, the nth term of any AP, that is, let's say Tn, is A plus n minus 1d, where A stands for the first term of the AP and d is the common difference. So for the first AP, I can write a formula that its nth term should be, the first term is 9 plus n minus 1, and the common difference being minus 2 in this case, right? So we can simplify this. 9 minus 2n plus 2. That becomes 11 minus 2n. We can do the similar thing to find, let's say, tn dash. That is the nth term of the second AP. This one we are talking about, the 15, 12 one. So here again we have 15, that is a plus n minus 1, and d out here is 15 minus 12 is, 12 minus 15 is minus 3. The common difference is minus 3. So again I can simplify it. 15 minus 3n plus 3. That becomes 18 plus, minus 3n. Now it was said that the nth terms are equal. So I can simply equate the nth term of the first and second AP. What we have with ourselves now is 11 minus 2n is equal to 18 minus 3n, which will give us, taking 3n on this side, n equal to 7. 7 term of both these AP are same. 7 would be the answer. Let's go to the next question. That is the third question. It was a internal choice. It had an internal choice. Let's solve both of them. It says 150 spherical marbles, each of diameter 1.4 centimeter, that makes the radius 0.7 centimeter, are dropped in a cylindrical vessel. So we have a cylindrical vessel and these spherical marbles are dropped, and this vessel had some water, let's say. So we have been given the number of spherical marbles which were dropped. Those are 150. The radius of each of them is 0.7 centimeter. And this vessel, cylindrical vessel in which it was dropped, its diameter is 7, which makes its radius as 3.5 centimeter, half of diameter. Now they're asking, like, once these are dropped, what would be the raise in the level of water? This, if the water rises by this amount, they're asking about this h. By what amount will it rise? So volume of the water raised should be equal of the volume of the total marbles we have inside this cylindrical container, right? Okay, so we can equate n, that is times the volume of each marble being spherical. It's 4 by 3 pi r cube. Let's write r with the subscript s to denote that it is the radius of the spherical marbles. This should be equal to this volume of this part of the cylinder. So it's pi r with the subscript c, that means it's cylinder radius, square h. This is the h we need to find. So writing it this way, you can straight away get rid of pi. Now we can simply plug in the values. So n was 150 into 4 upon 3 multiplied by 0.7 cube and whole divided by the radius of cylinder, which is 3.5 square, right? So we can do the simplification and we shall have the height. Okay, let's do it here itself. It's 2 powers will give me 5 and 5 here, and I'm left with a 0.7 here. These two terms are gone. I had a 3 below, which can cancel with this 50, and I can get 1 5 cancel with this 10. So I have 7 upon 5 with there's a 4 also. 7 4s are 28 upon 5 is the answer. That would be 5.6 centimeter will be the amount of height by which the water level raised up. So we can attempt the next question, that is the OR part of question 3 of section A. These 3 cubes of size 6 centimeter are placed the way they are shown in figure 1. We are asked to calculate the total surface area. So total surface area of a cuboid we know is 2 times LB plus BH plus LH. Now let's see in this figure, since 3 cubes are joined, so this length of the cuboid becomes 18 centimeters. 6 3s are 18. This, let's say the breadth still remains as 6, and even this height remains as 6. So we have all the values of L, B, let's say, and h. We can simply substitute in the values. It's 2 times of 18 into 6 plus 6 into 6 plus 18 into 6, right? So it's 2 times 108 plus 36 plus 108, which would give me 108 2 is 216 plus 36 is 252. Multiplied by 2 will give me 504 centimeter square is the complete surface area of this shape we have here. So the answer is 504 centimeter square. Let's move ahead. The fourth question in section A, it's from quadratic equation. For what value of m the quadratic equation given here has two real and equal roots? So the condition is the discriminant of the quadratic equation d, which is b square minus 4ac, should be equal to 0 for the equation to have equal and real roots, right? So we can simply need to put in the values of b, a, and c in this. So b from here is minus 2 m minus 1 whole square minus 4 times of a is m, and the value of c in the given equation is m plus 2. We need to write it within bracket. So let's take the square. Minus 2 square became 4, and we are left with m minus 1 whole square. Let's expand it as well. M square plus 1 minus 2m, and this opening the bracket would give me minus 4m square and minus 8m, right? Let's open the first bracket as well. 4m square got cancelled out. Minus 8m became minus 16m, and we are left with a plus 4. So now this has to be equated to 0, which would give me m is equal to minus 4 upon minus 16, that is 1 upon 4 is the value of m for this equation to have real and equal roots. So this answer is m equal to 1 upon 4. You can go to the next or part of the fourth question. It says, it's again, what is it? It's again on quadratic equation here. The diagonal of a rectangular field. So let's have a rectangle first. Let's say its length is L, its breadth is B. The diagonal of a rectangular field is 60 more than its shorter side. So let's say if this D is diagonal, it says diagonal is 60 meters more than its shorter side, that being B in our case. Further, the second statement says if the longer side is 30 meters more than the shorter side. So it tells me that L is 30 meters more than B. Fair enough? Find the sides of the field. Okay. So I can just write it in terms of two variables, right? So we have been asked to calculate the sides of the field. We have a simple relation from Pythagoras theorem that d square is equal to L square plus B square. We have the values, we can substitute them. 60 plus B whole square is equal to 30 plus B whole square plus B square. So it becomes 3600 plus B square plus 120B is equal to 900 plus B square plus 60B plus B square. So one B square on either side gets cancelled off. So what we are left with is 120 minus 60B is 60B. From these two terms I got on the left hand side, this would be equal to, and I have a B square also. So it comes here with a minus B square plus 36 minus 9 is 2700 equal to 0. Now let's write it in a better way. B square minus 60B minus 2700 is equal to 0. I hope we can solve it from here. So I'm moving to the next question. Okay, the fifth question from section A is from geometry, circles precisely. It says PQ and PR are two tangents from an external point P onto a circle with center O. If angle OPR, the one shown in figure, is 45 degree, we need to show that OQPR is a square. So I guess it's a straightforward question, right? As a theorem, we know that this angle subtended Just a minute. Yeah. This angle from an external point, if I draw, just give me a moment, there's some hitch. Yeah, yeah. Okay, it's red color. Let me just change the ink. Yeah, we are there. So coming back to the question, as a property, we know that from an external point, if I draw two tangents, they both are making equal angles with the line joining the center, right? So I know that angle OPR and angle OQR both are equal, since one is given as 45 degree, both of them are equal. So that makes that entire angle P of that quadrilateral OQPR as 90 degree. We further know that this angle now is 90. This angle also is 90 since it's a tangent. Even this angle is 90 degrees since again it is a tangent. That leaves me the fourth angle of the quadrilateral, angle O, which also has to be 90 degrees since the sum of all the angles of a quadrilateral is 360. So we have shown that all the four angles at the vertex are 90 degrees. So first job is done. It's not the only condition that we need to show that the figure OQPR is a square. We also would need to show that the adjacent sides are equal, which is straightforward since OQ is already equal to OR as it is the radius of the circle. So we need to show both the things, right? The angles at the vertex of the quadrilateral are 90 degree. We showed them straightforward. And further, the adjacent sides are equal, because just showing this condition, it can also be a rectangle. We were asked to specifically show that it is a square. Okay, I hope it's done. Coming to the last question, that is question 6 from section A. Last 2 marker questions students have today. Find the sum of first 20 terms of an AP. So Sn we know is n upon 2. 2a, or let me rather write it as a plus n minus 1 into t. What I've done here is I've just split the 2a term into a plus a. So now I can write sum of n terms as n by 2 a plus, this is simply the nth term ka formula, a plus n minus d, simply tn. Why I did it? Because we were asked to calculate the sum of first 20 terms. So the value of n is 20. Now the value of a we don't have, I guess, right? Directly given. What we have to ourselves is d is given as 5. So there's no point. And a20 was given to us as 135. So we can just write it as a plus 135. But we'll still need to calculate out the value of a from this. So it was given 20th term is 135, that is a plus 20 minus 1 is 19 into d is 5. 19 5 is 80. So sorry, 95. So a plus 95 is 135. That gave me a is 40. So I can now plug in the value of a here, 40. What we'll get? Sum of 20 terms is 10 into 135 into 4 will be 5 for the 20, 4 and 5. 5420. Right? 540. Oh, I had just to add them. I'm so sorry. 10 into, you just need to add them. I'm so sorry for the mistake. 175. So the answer comes out to be 1750. That is the sum of first 20 terms of this AP is 1750. We can jump to the next question. That is the first question from section B. From here onwards, the questions were for 3 marks each. It's a question from heights and distance, trigonometry. A tree breaks due to storm. Just a minute. Yeah. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. Okay. So if this so sorry for this first. Yeah. We're back in. So let's say we have we have Okay, so let's say we have this tree. This is the reference ground. Let's say it broke from some point and this part fell here, right? So this is now making an angle of 30 degree as the question says. So the total height of the tree is now this plus this length, right? Since it is the broken part which is not touching the ground. The height of the breaking point from the ground is 2 meters. So this distance is given as 2 meter. Find the total height of the tree. So we need to, let's say, find this point, the hypotenuse of this right angle x, let's call it x. We need to find x. So the final height of the tree, our answer would be 2 plus x meters, right? Since the entire question is meter. Okay, so we can apply the trigonometry to this right angle triangle. Let's call it ABC. Since we are asked the hypotenuse, we should not find out the tangent. Let's use the sine. Since sine 30 includes both the sides, we have here perpendicular, which is 2, divided by hypotenuse, that is to be found x. Sine 30, as we know, as half, is equal to 2 upon x, which gives us x is equal to 4. So we have already got this height, length x, the broken part of the tree. So the height of the tree is simply 6 meters. Simple question, right? Okay. We can come to the next question of section B, that is our question 8. What we have here is a question from statistics. We are asked to calculate the median from this data, right? So it's a straightforward question, I guess. I'll do it right here. We'll make a table first, a column for cumulative frequency. So it's 16 plus 14, 30, 48, 68. I copied something wrong. 48, 68 plus 18 will give me 96. Plus 12 is 108, plus 2 is 110. So first thing, we already have that the value of n is 110. So we calculate n by 2 to find the median class. So it gives me 55. So the just value above 55 is this. So this becomes our median class. This 45 to 50 class interval becomes our median class. Now I hope everyone knows the formula for median. It is L plus n by 2 minus cumulative frequency of the preceding class divided by frequency of the median class multiplied by the class size. So the lower limit of the median class is 45, n by 2 was 55, the cumulative frequency of the previous class is 48, and the frequency of the median class is 20, to be multiplied by the class size, which is 5 in this case. So this 5 and 20 can cancel off to give me 4. So we have 45 plus 55 minus 48 is 7 upon 4. Right? So we can calculate and have our answer. It's 46 point, what will have 3075, something like that. Okay, so this is the answer for this question 8, 46.75. This is the median of the following data. Let's come to the next question of section B. It says draw a line segment AB equal to 8 centimeter and locate a point P on it such that AP is to PB is in the ratio 1:5. So it's a question from construction. I hope everyone knows this. We can draw an acute angle here, divide it into 1 plus 5, 6 equal intervals, 1, 2, 3, 4, 5, 6. Join the last interval with B. Just a moment. Yeah, join the last interval with B. And from the first interval, draw a line parallel to the previously drawn line. So you have to just draw this line parallel using compass. Wherever this line intersects, that would give me the point P. I hope it's clear. Everybody would have done this. The OR part is also a question from construction. It says we have a circle with center, with radius 3 centimeter. Just a minute. Yeah. We have a circle of a given radius which is 3 centimeters. So everyone can first draw a circle of 3 centimeter. Then it says from a point 6 centimeters away, let's say this center was O, this point is P. This entire distance OP is 6 centimeters. From here, we need to draw two tangents to the given circle. So I guess everyone knows this. Firstly, we need to draw the perpendicular bisector of this line segment OP. We take some suitable radius more than half this distance, make the arcs from both the centers O and P, and draw the perpendicular bisector. Let's say it intersects at point X. Now with this X as center and this radius, we need to draw a circle. Let's draw a circle. Now where this circle intersects our main circle with center O, these are the points we simply need to join from that external point P. So this is how we draw tangents to a given circle from any external point. I guess every student attempting this would have done it correctly. Okay, we were nowhere asked to write the steps of construction, but few of us have already written it, that's okay. Coming to the next question, the last question of section B, the 3-marker question. It's again a question of statistics. We have been asked to calculate the mean using the assumed mean method. So again, we can do it here itself. First, we'll need to find the class marks of this continuous frequency distribution. We'll need more columns, so let me just extend these lines. Let's say I have the first column. What I make is xi, that is the class mark. So 100 and 110, the class mark or the average will give me 105. Next 115, 125, 135, and lastly 145 are the respective class marks of these classes. Now since it's assumed mean method, the first thing what we do, we assume a mean somewhere from between. So let's say our assumed mean is 125, right? Okay. Next, we need to find the difference. Let's take di, make a column which is defined as xi minus a. I hope everyone knows this. So 105 minus 125, this gives me minus 20, minus 10, 0, plus 10, and plus 20. Now the next column is the multiplication of this previous column di with the corresponding frequency. So minus 20 into 4 is minus 80, minus 10 into 12 is minus 120, 23 into 0 is 0, 8 into 10 is 80, and 3 into 20 is 60. So now the mean, as we know from the assumed mean method, is simply A plus summation DI upon summation Fi into H, right? So let's calculate the sum of these two columns, the frequencies first. 12 plus 4 is 16, plus 23 is 39, plus 11 is 50. So summation Fi, the denominator we have is 50. Let's calculate the sum of this column, di into Fi, which we have constructed. Minus 80 and plus 80 gets cancelled. Minus 120 plus 60 is minus 60, right? Okay. So it's A is 125 plus summation came out to be minus 60 upon 50. I'm so sorry, I wrote H here. It's into 1 by H, right? It's divided by H. Okay, and my H in this case class size is 10. So we can cancel this. We have our answer as 125 minus 6 upon 50. That is very nearby 125, right? 125 minus 0.12. So precisely my answer is 124.88. This is the mean found by the assumed mean method. Okay, so we have also completed section B discussion. We can next move to section C. Here the questions were for 3 marks. Okay, most of the feedback which I got immediately after the paper said like, so the questions from section C, especially the case-based questions, were difficult to face, right? Especially in the standard paper. So we'll just come to them shortly. Let's start with the 11th question. Okay, again a trigonometry height and distance question. It says the angle of elevation. Just a minute. Let me just clear this and give more space.
अब फिर मैं अपना
Okay. Yeah. So I have a plane here whose angle of elevation right now is from the ground is, let's say, 60 degree at first, right? Now it travels some horizontal distance at a constant height. So this height remains constant, right? This height we are talking about.
बोलो बिल दिखाया था और 2,500 रुपये महीना और मेरा जो उसके साथ
Could you please switch off your microphone?
आ देगा अक्टूबर के बाद 25,000 वो नुकसान
Excuse me, couple of you are like discussing. Could you please switch off your microphones?
बिल्डिंग में रह रहा हूँ, कम स्पेस में रह रहा हूँ, अपना स्पेस खाली पड़ा।
Okay. Anyways,
so I'll just
draw the diagram again. This is what the figure would look like. It at a constant height flew to some distance, let's say. The time it took to go from A to B is given to us. It is 30 seconds. At A, the angle of elevation from the ground was 60 degrees. And when it reached B, the angle of elevation became 30 degrees. Right? So this two triangles can be seen. Let me mark these vertex as C, D, and E. Now we have been asked to calculate the speed of the plane. Now, considering the plane to be moving with constant speed, it is simply distance upon, right? So we need to basically calculate this distance AB out here, or the distance ED. Teachers, if at all there is some problem, we can discuss them at the end. In triangle ACE, firstly I can write this.
So there is a doubt. I'm sorry to disturb. Miss Joya has written calculations are wrong for question number 10. Can you please discuss that again once?
Surely, I might have gone somewhere wrong.
Yeah.
Okay.
You can just please check it out. Yeah.
Could someone just point me out?
Sir, value of h is multiplied by 10. You have divided, I think.
Okay.
Yes.
So sorry for the mistake.
60 upon 50 into 10.
Sorry. So this 10 will get multiplied out here. So minus 60 by 50 would be minus 1.2. Multiplied by 10 would be 12. So 125 minus 12 will come out to be 113. My bad, teachers. Thank you for the correction.
Sir, for the median sum also, your total was 110. It's 100 actually.
For the median sum, the total.
68 plus 18 is 86, right?
Okay. Thank you. So this was 86 plus 12 was 98.
Yeah, and 100. But that didn't
And 100.
the frequencies. That's why the answer is
So
right.
I guess the median class will remain same.
Yes.
Thus we got the answer as same, but yeah, thank you for that correction too. Okay. I guess we can move ahead. So we
Yes, sir, I guess there was only one doubt. Yeah.
Okay. So moving ahead, we are here. So we need to calculate the speed here. So we need to find this distance AB. We have already been given the time as 30 seconds. So in the first triangle ACE, we can apply tan theta. Let's take this height BD to be h. Later we'll substitute the value. So tan 60 in this triangle is h upon CE, right? In the next triangle, I can write tan 30 is equal to h upon CE plus AB. That is the required distance we need to find. So we could have even taken some values here. Let's say we could have taken it to be y, or taken it to be x for, so that we need not write this expression CEAB all over again. So we can substitute the values now. So firstly, I'll get CE comes out to be h upon √3 from my first equation. I'm putting CE on one side of the equation since I need to eliminate it. Similarly, from the second equation, I can write CE plus AB is equal to √3h, right? Tan 60 was √3, so it became h by √3, and this is √3h. From these two now, I can substitute the value of CE here to find AB. So my AB comes out to be √3h minus h upon √3. We can take the LCM. It's √3, 3h minus h. right? So it becomes 2 by root 3 h. We can further rationalize it also. We can write 2 by 3 root 3 h. I guess we have arrived at our expression. The value of h in the question was given as 3000 root 3. So if I write 2 by root 3 into h, which is 3000 root 3, this root 3 gets cancelled and we are left with 6000 meters as the distance AB. So now finally we can calculate the speed. 6000 meters upon 30 seconds will fetch us, just a moment, 30 seconds would give me 200 meter per second was the speed of the plane in this case, right? Okay, let's come to the 12th question, part A. It's again from circles. We need to show that this point C is bisecting the line segment AB. So as we can see, there is a smaller circle with the center O prime. This angle OCA, this angle has to be 90 degree, as any triangle formed in a semicircle, the angle is always 90 degree. Now we further know that if we draw a perpendicular from the center on any chord, it bisects it, right? We could further show the congruency also in the triangles OAC and OCB, and we can show that yes, AC would be equal to CB. Since OA is equal to OB is the radius, angle 90 is same, and this OC is the common side. So the triangles OAC and OCB are congruent by RHS criteria, and thus we can say that AC is equal to BC, or C bisects the line segment AB. Okay, I guess it was clear. Coming to the next question, I'll have to move the slider. Just give me a moment. Yeah. So what we have here is another question from circles. O is the center of a circle whose radius is given as 5 centimeters. So this distance is 5 OA. PA and BC are tangents. Okay, these are tangents to the circle at A and B respectively. If OP, this distance is 13 centimeter. We need to find the length of tangents PA. So I guess PA though straight away comes from the hypotenuse triangle. From hypotenuse we need is already given as 13. We need to find the side PA of this right angle triangle OAP. So PA is simply 13 square minus 5 square. That would give me 12. So the first task is done. The length, this PA is 12. Second task is to find the length of the tangent BC. Now in triangle BPC, we can apply the Pythagoras theorem. This length BC, we don't know. Let's take BC as X, as a property that the tangents from an external point are equal in length. This length CA is also X. So this PC can be written as 12 minus X, right? And the side BC of this triangle is X. Further, PB can be simply written as the length OP minus the radius 5. So it's 13 minus 5 is 8. So let's apply the Pythagoras theorem in this triangle BPC now. The hypotenuse is BC, so let's keep it on one side. 12 minus x whole square is equal to sum of squares of the remaining sides. We can solve this quadratic equation, and I guess we will have the answers to ourselves. Minus 24x. Actually, it will be reduced to a linear equation, as we can see. So it's 24x is equal to 6480. X is equal to 80 upon 24. This is 10 upon 3 centimeter. So this is the length of BC we have formed, right? Okay, we can move to the penultimate question, question 13. What we have here was a simple question from mensuration. We have a pool which has some sidewalk, right? A walking area on its side. So from the top, if we look at from the top, this is what we are looking at. And this is the pool with water in it, right? Okay. Now the outer edges of the sidewalk are given to us. So this length is 7 meter. And this length, let's just a minute. This length is given as 12 meters. Let's take this width as asked in the question to be x. So it's uniform on all sides, right? Everywhere the width is x. We are used to doing such kinds of questions. So now the effective length of this pool, this area, this rectangle ka breadth remains as 7 minus 2x, and the length gets also reduced by a factor of 2x, which becomes 12 minus 2x. This should be given or equal to the area of the pool, which is 36 meters square. So I guess we have already solved the question, right? We have made the quadratic equation in x we were asked. We'll just need to simplify it a bit. Let's do it here. 12 sevens, yeah, 84 minus 14x minus 24x plus 4x square is equal to 36. So 4x square minus 38x plus 48 is equal to 0. So we'll have to split it, solve it. This can be done from here, I guess. That was the second part, also get answered once we find the value of x. So we can take a common factor of 2 out of it. So it is 2x square minus 19x plus 24. So now we need to split this middle term. It comes as 48. 16 3s are 48. So it becomes 2x square minus 16x minus 3x plus 24. Taking 2x common, it becomes x minus 8 minus 3 common, x minus 8 equal to 0. We would get the values of x as 8 and the other value would be 3 upon 2. So obviously we'll have two values of x, but we'll have to discard one value, right? Since this entire length is 7, so there is nowhere this x could be 8. So the only correct answer out here would be 3 by 2 or 1.5 meter. That is the width of the sidewalk all around the swimming pool. So I hope the first case study is clear. Again, the last case study was broken down into two parts of 2 marks each. It said, just give me a moment. John planned a birthday party for his younger sister with his friends. They decided to make some birthday caps by themselves and to buy a cake. So obviously there are two things. There's a cake, there are caps. Now cake happens to be a cylinder of this dimension, of diameter this and height this, while the caps are conical as can be seen in the figure. Now the two questions are, how many square centimeter paper would be used to make 4 such caps, right? So it's a hollow cone, right? That is a cap, as we all know, birthday caps. So we simply need to find the curved surface area of each cone, multiply it by 4, and we should get the first answer, answer A. So let's do it. It's pi r l into 4. That should give me the total surface area of the paper required to make 4 such conical caps. Okay, now what parameters for the cone have been given to us? We have been given the height of the cone as 24. Further, the circumference of the base is given as 44. So we know circumference is 2 into 22 by 7 into r, that is 44. So that gets cancelled off. So the radius of the cone we know is 7 centimeter. Now we need to find the slant height L. So let's use the Pythagoras theorem. We will get root under 24 square plus 7 square, that is root 625 will come out to be 25. That is the slant height. Let's plug in the values. 4 into 22 upon 7. The radius we got as 7 multiplied by the slant height, which is 25. So 25 4s are 100 and 22 is 2200 centimeters square would be the answer for part A. Okay, let's come to the part B. It says the cakes can be made in some standard weights, right? Like half a kg, 1.5 kg, 1 kg, and so on. It cannot be of 300 grams or 400 grams. We need to calculate how much, or rather the better word would have been, how many cakes should they order if there is a density scenario given here, right? If the 650 centimeter cube, that is the volume of K, weighs 100 gram, how many cakes should be ordered? So we have already been given the dimensions of the cylindrical cake. So first let's find the volume, which for a cylinder is pi r square h, that is 22 upon 7. Since the diameter is given as 24, let's split it into half, 12 square, that is 12 into 12, multiplied with the height, which is 14. So we can cancel 7 and 14 too. And we'll need to do this maths, right? Okay. So 12 square is 144 into 44 would be 16, 576. 576 gives me 6, 3, 3, and 6, right? Please check the maths tutor. Okay. So we have 6336 as the total volume. We could have even skipped this part of calculating, could have simply got it cancelled. Okay, let it be, chalo, now it's done. So this is the volume, total volume of the cake. Now we know that we can simply apply unitary method. This much of volume of the cake weighs this much. So how much will this much weigh, right? So if 650 centimeter cube is 100 grams, 1 centimeter cube would be 100 upon 650, and 6336 would be equal to 100 by 650 into 6336 grams. 0 and 0, let's get cancelled away. I hope this will totally get cancelled off. 65. Let me just use a calculator for a bit. 6336 divided by 65. No, it does not get cancelled off. Okay. Okay. So it's coming out to be, I might have done a mistake somewhere. Let me just cross check. The volume of the thing was pi r square h. 144 into 44. That came out to be 6336. That is correct. Okay. So I guess this question will have some answer with decimals, right? So this much centimeter cube of cake is coming out to be 6336 into 10 divided by 65 comes out to be 974.7 grams, right? So how many cakes can be ordered here? This seems like a tricky number we have. Any clue, teachers? Did I go somewhere wrong with this question? Because out here I can give the approximate weight as 1 kg. I can ask 1 kg cake or 2 half a kg cakes. Yeah, somebody did raise a hand. Yes, ma'am.
Sir, I think 1 gram should be 160, sorry, 650 upon 100.
No, ma'am, that's so fine. If this was the column of, ma'am, centimeter cube, that is volume, this was for the mass in grams, right? So if 650 centimeter cube or 100 grams, 1 centimeter cube has to be 100 by 650 grams only.
Acha, 1 centimeter. Oh.
So I guess, yeah, probably this is the answer. I don't know, it got stuck here. So this is it. Any doubts, you may please ask in any relevant question. You can type in the chat box, please.
So this is which set and which region?
I guess, ma'am, most of the questions were same for all the sets. If there is at all a question which was there in a particular set and there is a problem with that, you can please share with us.
Yeah, there were
So-
case studies were different, as well as one circle question also in section C.
Okay, there might be, ma'am. I guess this was set 3rd.
Sorry, sir, can we now take the doubts of everyone?
Sure.
Yeah, so you may either unmute your mic or you may either write in the chat box. So both the ways are welcome. So sir will take all your queries now if you have any.
I guess we don't have any queries.
Right, sir. So I guess all the doubts were clear to everyone. So we may end the webinar. Thank you so much. Thank you, Ms. Purnima. She already written, there's no doubt. So thank you so much. Thank you so much, everyone.
Thank you, ma'am.
Thank you so, Shaurya, sir. Thank you so much.
Thank you, everyone. Have a pleasant day.
Thank you, ma'am.